Welcome to The Explainer. Today, we're exploring a seriously fascinating and honestly highly practical technique straight out of the Learn Prompting Guide. We're looking at a method called self-generated in-context learning. We usually just call it SG-ICL for short. Now, if you've ever found yourself pulling your hair out over the limitations of standard prompt engineering, specifically, that endless, tedious hunt for the perfect examples to feed your AI, well, this is absolutely going to be a game changer for you. So let's dive right in and optimize how we teach AI to do exactly what we want. Here is our quick roadmap for today. 1. The few-shot data problem. 2. What is SG-ICL? 3. The two-step process. 4. SG-ICL in action. And finally, 5. Pros, cons, and use cases. All right, part 1. The few-shot data problem. The bottleneck of external datasets. So to really understand why this is a problem, we kind of have to look at how we usually prompt these models. Typically, we use what's called few-shot learning. That just means we give the AI a few input label pairs, we call them exemplars, just to help it figure out a task without having to, completely fine-tune the entire model from scratch. But here is the massive catch. Those demonstrations, they're almost always pulled from external datasets, and that introduces a huge bottleneck. You literally have to go hunt down or manually create all that data yourself. It's exhausting. But what if an AI could just teach itself? Think about it like a student who, right before taking a big test, sits down and brainstorms their very own practice examples just to warm up. Which brings us to section 2. What is SG-ICL? Let's define self-generated in-context learning. Self-generated in-context learning is basically a technique to generate those exemplars for a standard few-shot prompt. But instead of finding them yourself, you ask the language model itself to generate them. It drastically reduces our reliance on external datasets. Think about it. Instead of you going out to some database to scrape 5 examples of a positive movie review to show the AI, you just ask the AI, hey, write 5 positive movie reviews first, and then you use those exact reviews as your examples. It is such an elegant solution to a really frustrating bottleneck. Looking at where this fits into our prompt engineering toolkit, you can see a really clear progression. On one end, you have zero-shot learning. That's where the model is performing a task entirely blind with 0 examples or context. It's just guessing based on its pre-training. Then you have standard few-shot learning, where you're relying on a small number of manually selected external training samples. But SGICL, it eliminates that external training data requirement entirely by generating its own in-context examples. It totally bridges the gap. You get that sweet performance boost of few-shot learning, but without any of the manual labor of actually tracking down the data. All right, section 3, the two-step process. Let's look at how this mechanism actually works under the hood. The absolute crucial thing to grasp here is that this whole thing happens in 2 distinct phases. Step 1 is the self-generation step. This is where the model acts as the creator. It generates exemplars that are closely related to the specific task at hand. And this is awesome because it actually improves the correlation between the input and the demonstration. The examples are hyper-specific to exactly what you're trying to achieve. Then we move to step 2, the inference step. The model takes those freshly generated samples, uses them as its few-shot exemplars, and finally predicts the answer for your actual real-world test input. Let's look at the actual templates used for step 1. Say we're doing sentiment analysis. The prompt gives the AI a tiny nudge, something like, generate a review, a fast, funny, highly enjoyable movie, followed by, generate a negative review. It's super simple. And you can see this works for other things too, like recognizing textual entailment, where the AI is nudged to generate true or false hypotheses based on a premise. Basically, this initial step is essentially just a tiny few-shot prompt of its own, with just a single exemplar, designed purely to trigger the AI to brainstorm those practice examples we were just talking about. Now, moving into step 2, we use an inference template. For sentiment analysis, you'd format it really simply. Review, text, sentiment verbalizer. Now, don't let the word verbalizer trip you up. The verbalizers are just the specific output words you're looking for, like positive or negative, or true or false if you're doing an entailment task. So you just stack your self-generated examples using this template, and then at the very bottom, you place your actual target question. Moving on to section 4, SG-ICL in action. Let's look at a real-world restaurant review. Imagine for a second you're building a system to categorize customer feedback, and you receive this specific target review. The food was amazingly bad, and the service wasn't anything to write home about. Okay, you need the AI to determine the sentiment of this text. But remember, the whole point here is we do not have a pre-existing data set of reviews to guide the AI. We are starting completely from scratch. No training data whatsoever. So we initiate step 1, self-generation. We ask the model to just generate a positive review. And the AI, totally on its own, outputs, "The food was insanely good." Boom. Just like that. We now have our first exemplar, and we didn't have to waste time scouring Yelp or digging through some massive database to find it. Next, we continue step 1 and ask it to generate a negative review. The AI spits out, "I could have gone back home and made homemade lasagna in the time they took to complete my order." I mean, that is fantastic, right? It adds perfect natural conversational context, it clearly understands the nuances of a negative restaurant experience, and it generated this purely from its own internal weights, no outside help at all. Okay, now we move to step 2, inference. This is where it all comes together like a giant puzzle. We take those outputs from step 1 and combine them with our actual target review. Notice the logical structure we're using here. We provide the positive example, and we literally label it positive. We provide the negative example and label it negative. Finally, we drop in our actual target review, "The food was amazingly bad," and we intentionally leave the sentiment blank for the AI to fill in. We've effectively just built a highly tailored, task-specific, few-shot prompt entirely out of thin air. And the result? The final AI output is correctly negative. The method works beautifully. By letting the AI sort of prime itself with its own self-generated context, it easily categorized the target text. It's almost like magic, but it's just really smart prompting. Section 5, pros, cons, and use cases. Let's talk about the trade-offs of SG-ICL. Let's start with the good stuff, the benefits. The absolute biggest win here, hands down, is that absolutely no external data is required. This makes the technique incredibly intuitive, extremely easy to use, and frankly, very fast to implement. But there's another subtle yet super powerful benefit: low variance in performance. Because you are essentially forcing the model to generate examples that are hyper-specific to the exact task you are running right in that moment, you actually get more consistent results compared to just randomly picking demonstrations from some massive generalized dataset. Of course, we do have to talk about the limitations. We can't ignore them. SG-ICL fundamentally sacrifices a certain degree of ultimate quality for that speed and ease of use. If you were to test it against really advanced, dataset-heavy techniques, things like k-nearest neighbors or vote-k, it is going to underperform, for sure. Those methods are computationally expensive, but they are rigorous. So your main takeaway here should be that SG-ICL is absolutely best used when you just don't have a dataset available, or when your computational resources are a bit tight. It really acts as the ultimate quick start solution. Which leaves us with this final, kind of provocative thought. If models are already capable of generating their own highly effective training examples to improve their own logic, how will self-generating AI change the future of prompt engineering? Like, as these models get smarter and smarter, will we even need external datasets for basic tasks anymore? Or will AI become entirely self-reliant in how it learns in context? It's a seriously thrilling direction for the technology. Thank you so much for joining me on this explainer, and hey, keep experimenting with those prompts.